We all just assume that flying is the safest way to travel. And it is. But that incredible safety record wasn't a happy accident. It was built, piece by piece, from the lessons learned from tragedy. Today, we're diving into an invisible revolution in air safety, one that was sparked by two heartbreaking crashes over the very same ocean.
Okay, so picture this, the late 90s. The aviation world gets rocked, twice. First, in 1996, TWA Flight 800, a massive 747, just explodes out of the sky. Then, only 2 years later, Swissair Flight 111, an MD-11, goes down in that same stretch of the Atlantic after a fire started on board. So you have two different planes, two totally different events. One's a fuel tank explosion, the other's an in-flight fire.
I mean, on the surface, they look completely unrelated, right? But as the investigators started piecing together the wreckage from both planes, they began to suspect there was some kind of hidden connection. So what on earth could be the common thread here? To get to the bottom of it, we're going to follow the investigation. First, we'll look at the catalyst that kicked everything off. Then, we'll see how they had to completely redefine the problem itself. After that, we'll cover the brand new rules they wrote. And finally, we'll look at the surprising math behind the price of safety. All right, first up, the catalyst. The investigators knew that a spark had to have set off the fuel tank on the TWA flight, and they knew a fire brought down the Swissair plane. The big question was, where did that spark, that fire, come from? And here it is.
The one thing that connected both of these horrific accidents was something you and I never think about when we get on a plane. The miles upon miles of electrical wiring snaking through the aircraft. This single discovery was about to change absolutely everything.
And that leads us right into our second part. Because once they started focusing on wiring, investigators realized their entire way of thinking about it was just wrong. It was dangerously incomplete. So to get everyone on the same page, the FAA basically had to invent a whole new term, the Electrical Wiring Interconnection System, or EWIS. And look, this wasn't just some new piece of jargon. It was a massive philosophical shift. It forced the entire industry to stop looking at a single wire in isolation and start looking at the entire ecosystem that holds it all together.
And get this, look at what's included here. We're talking about the connectors, the labels, even the simple plastic cable ties. Why? Well, because they realized the failure of one tiny little clamp could let a whole bundle of wires rub against a sharp metal edge and, eventually, spark. Every single little piece of the puzzle mattered.
But then came the real mind-blowing discovery. The biggest threat wasn't necessarily that wires were old and brittle. No, the real kicker was that they were dirty. And that insight completely changed where they focused their safety checks. It all comes down to the simple fire triangle we all learned in school. In a plane, you've always got oxygen. A frayed wire can give you the ignition, the spark. But what's the fuel? Well, it turns out the fuel was the contamination itself. And just listen to what investigators actually found. They described wires literally caked in this nasty, flammable cocktail of dust, lint, oils, and even tiny metal shavings. This gunk would build up over years, hidden away, creating the perfect fuel to turn one tiny little spark into a catastrophe. And believe me, this wasn't just on one or two unlucky planes. They formed a committee to go out and inspect fleets of older aircraft, and the results were just jaw-dropping. I mean, look at this table. On just 14 DC-8s, they found nearly 1,000 wiring problems. 9 Boeing 737s had almost 400. This was a massive, systemic issue across the entire industry. So, with all this shocking evidence piling up, the FAA knew they had to do something drastic. They had to completely rewrite the rulebook. Okay, this next part is a really big deal. You have to understand, normally when a new safety rule comes out, it only applies to new planes, the ones that are still on the drawing board. But the FAA did something almost unheard of. They made these new wiring rules retroactive. That means they applied to every single plane that was already flying all over the world. And the way they did this was through something called the Enhanced Zonal Analysis Procedure, or EZAP. This basically forced manufacturers to go back through their old designs, zone by painstaking zone, and reevaluate everything through this new, harsh light of wiring safety. It was a monumental undertaking, but it was absolutely essential. Now, beyond the big picture stuff, the investigation also uncovered some very specific and frankly painful lessons.
The fire on Swissair 111, for example, was traced back to its brand new in-flight entertainment system. And what they learned from that changed cockpit design forever.
So here's the thing they figured out. When the entertainment system started acting up, the crew had no way to turn it off except to pull its circuit breaker. But here's the catch. A circuit breaker is meant to be an automatic safety device, like a fuse. It is not designed to be used as an on-off switch. Using it that way causes wear and tear, which means it might not work when you actually need it to save you. And the FAA did not mess around. Their response was swift and absolute. They officially called it an unsafe condition and immediately put out a directive that grounded every single plane with that specific system installed. This led directly to a new rule that all non-essential systems, like entertainment, have to have their own dedicated on-off switches in the cockpit. All right, this all brings us to our final chapter, the price of safety. Making all these changes across thousands of airplanes was, as you can imagine, ridiculously expensive. But was it worth it? Well, the math is actually pretty surprising. First, the cost, and it was enormous. We're talking about almost $500 million for the entire industry to get the entire global fleet up to these new standards. But then you look at the other side of the ledger. The FAA calculated the total benefit of doing all this work, and it came out to more than $755 million. The investment in safety would literally pay for itself, and then some. And these weren't just fuzzy numbers. We're talking real-world results. The analysis figured that over 25 years, these new rules would prevent at least one fatal crash, stop over 700 unscheduled landings, and cut down on expensive flight delays, all things caused by wiring problems. It turns out, safety isn't just the right thing to do, it's just smart business. So what's the big takeaway here? The next time you're on a plane, maybe settling into your seat, just remember this. You are surrounded by an invisible network of safety, a system that was born from tragedy, built by painstaking investigation and innovation, and it's there, quietly working to protect every single flight. And that really makes you think, doesn't it? This whole story was about aviation, but it begs the question, what other invisible systems are out there? What are the quiet heroes in our daily lives, working behind the scenes to keep us safe?